Hello, everybody. Welcome to tonight's NYU Stern Fubon Center fireside chat, part of our Demystifying AI series. Our topic for this evening's chat is, what is AI and what isn't it? What can it do and what can it not do? I'm your host, Foster Provost, and this evening I have the great pleasure of introducing Gary Marcus. Gary is a professor emeritus at NYU, perhaps the youngest, and one of the clarion voices in the current debate about what really is the state of modern AI. Gary was founder and CEO of Robust AI and of Geometric Intelligence, the latter a machine learning company acquired by Uber in 2016. Gary's the author of 5 books, including, I have to read them, The Algebraic Mind, Kludge, The Birth of the Mind, the New York Times bestseller Guitar Zero, and his latest book, co-authored with our NYU colleague Ernie Davis, Rebooting AI, Building Machines We Can Trust, which if you're in the audience tonight, you probably ought to read. Gary's been studying intelligence and learning, including AI, for his entire professional career, as far as I can tell. His 1993 PhD thesis was on child language acquisition, generalization, and neural networks, the AI kind. And I also wanted to point, which I only learned about in talking to Gary prior to this, about Gary's recent writings on Substack, which again, if you're interested in this topic, you really want to check out. If you just type his name and Substack into Google, you'll find it. I hear we have had 460 registrants tonight, so that's a really nice audience. So let's jump right in. Hi, Gary, welcome. It seems like you've been really busy lately, from what I've been reading.
I've been writing a lot. By the way, it's garymarcus.substack.com to save you the Google query. I've been pretty busy. There's a lot of misinformation around AI these days, and I'm actually concerned about AI creating misinformation. And I think that one needs to have a background in cognitive science to really appreciate what's going on. I think that there's a lot of hype out there, and it's easy, if you don't really understand what cognition is, to get caught up in the excitement. And it's important, I think, for people to be able to distinguish between where we are making progress and where we're not making progress. And if you just sort of think of AI as magic, then when you think that there's progress in one place, you automatically assume that there is in others. One of the most famous mistakes like that, I think, is that IBM thought, okay, we beat Jeopardy. We have this amazing piece of AI. We'll just go throw it at the hardest problem we can think of, which would be oncology, and it'll all be great. And you have John Kelly goes on Charlie Rose and says, we're going to change the world. And after that, the stock tanks for like 16 quarters or 26 quarters in a row because they never actually deliver the goods. And in some ways that was hubris. And the hubris was around thinking that because I've solved one AI problem, I can solve them all. The reality is that every piece of cognition is different, and every problem that you want to solve in business is different. And so I like to think that I have some perspective there as someone who's studied both how children learn about things and how AI learns about things. And I also like to think I'm not afraid to speak truth to power and call bullshit. And that makes me unpopular in some quarters, popular in others. And maybe that's why I'm here today.
Well, terrific. Actually, I think that's part of it, although I hadn't really realized the extent when I invited you. But I have to say that it was a delight to actually wade through. I haven't read it all, I have to say. The right way through your writings, and I'd been a fan of your writing before, which maybe we talk about a little bit later. But I thought maybe since we have these like sort of questions in the title, that maybe we could start off simply by just, what is AI? And then you can sort of unpack some of these things.
We'll start with a hard one. It's not as easy as you think, right? So AI means artificial intelligence. And so that should make you think of natural intelligence like we humans have or honeybees have. And already once you think about it that way, you realize there's a lot of things involved in intelligence. It's not one thing. If I had one definition, it might be like the ability to adaptively solve new problems or something like that. But that would be stacking the deck. I mean, really, there are lots of facets of intelligence. You have people like Howard Gardner, Robert Sternberg, saying that intelligence has a lot of facets. And I think that's right. It's not a one-dimensional variable. If you think about the IQ test, it kind of initially makes you think like there's just one number. This guy's IQ is 112 and this other person's 72 and whatever, as if it was just one number on a scale. But the reality is that we have different kinds of intellectual talents. So there's, verbal intelligence and mathematical intelligence, kinesthetic intelligence, whatever intelligence a great basketball player has, I don't have that. So, be able to stuff yourself in a corner in a particular angle while doing all this, at rapid speed. So there's many things that go into intelligence. And we know how to build some of those into machines. And sometimes we do it by copying what humans do, and sometimes we don't. So a good example where I would say it's intelligence is playing chess well, and we have machines that can play chess very well. Another thing that I would say is a hallmark of intelligence is having a conversation, a coherent conversation. I would say you and I are doing that, and no machine can do that right now. We have machines that kind of fake it, but very quickly you realize that they are faking it. Like
we'll get into
they don't
that.
know if they're a machine or a person or where they are or what day it is, right? So they can fake it a little while. They can fool a stupid person or a naive person, but they can't fool an expert. And so they're not very good at whatever it is that goes into conversation. I think the biggest hallmark of human intelligence is that even a child can learn a lot of new things very quickly. So you take a 8-year-old child and you say, I bought this new game at the store, you want to play? And they're like, what are the rules? And 3 minutes later, they're playing that game. Maybe not at world-class levels, but they picked up the rules by verbal instruction, how to play this new card game or new board game, or how to do something physical, some new sport or whatever. And we don't have machines that can really do that. The machines that we have right now, most of them take a lot of training to do whatever it is they do, often measured in megabytes or gigabytes, and sometimes taking months of training and what have you. There's a kind of flexibility that is, I think, a hallmark, maybe not the only hallmark, but a hallmark of intelligence that machines don't have. And so when you want to know, can a machine do this thing now? You have to dive into the details. You can't just say, well, they're smart now, they can do stuff. Like, depends what you're talking about. They're not smart enough to be domestic robots now. So Elon Musk is talking about Optimus. I think most of us would agree that the demo was uninspiring, let's say. But aside from the fact that his robots were sort of stiff and moving slowly and stuff like that, they didn't have the intelligence that would make them comfortable in your home. So like there was a demo of a robot pouring water. Well, actually there was no water, pouring an empty water pitcher into a plant. It was a little bit fake, according to some people on Twitter, but I didn't mean to go into that particular spot. But there's a demo of it tilting the water pitcher. But if you actually wanted your robot to pour water into your plants, it would have to understand what the plants are, where they are, how much water to put in, stuff like that. You'd have to have some sophistication about the world. We don't have AI that's anywhere near that. So even if we could get the motor control right, the motors of tilting the robot arm in the correct fashion, we don't have the technology right now to build a generally intelligent robot that can participate in the world. On the other hand,
I was just going to, please finish. I want to get into this generally intelligent versus other things that people call AI.
We were talking about narrow intelligence, you and me, the other day, where you had a different term for it. On the other hand, we can build a machine that can play chess. We can build machines that can place advertisements pretty well. And you know a lot more about that particular domain of application than I do. What it basically turns out to be right now in 2022, but this may change eventually. But right now, we're better at building narrow intelligence than general intelligence. So when my wife and I had children, we created, 2 general intelligences that are now 8 and 9 years old. And those general intelligences can go to school or read a book or whatever and acquire new things. They're not necessarily world-class at anything that they do, but they can pick up a lot of different things. Whereas the way that AI mostly works right now is mostly people use machine learning with a lot of data focused on some very narrow problem. And in some cases, the results are spectacular. The most spectacular thing I would say is AlphaFold, which solves, maybe not perfectly, but solves quite well the protein folding problem. I've got a string of amino acids, and I want to know what shape is this going to be. And AlphaFold is tailored to that problem and no other problem. And it does it better than any other system ever did it before. It's really impressive. but it's a little like a calculator. Like a calculator kind of does some things. It's not very general. Most of the things that we know now, arguably all of them that we know now how to build, are narrow intelligences. And I think we'll talk later about like what is the impact for that in the commercial world. And I think that's a good question. But just to get like, what do they call it? Like level setting. The reality of where we are is that we know how to build narrow intelligence for some problems, not all. So like driverless cars have been a failure so far. Medical AI is still struggling. So some narrow problems we can't solve, some we can. And then we have nothing really that looks like general intelligence. We may someday. There's no logical argument that says that's impossible, but we haven't made much progress there.
Right. So good. So I wanted to clarify that. Thank you. And because I think what we're going to spend now a good bit of time is actually talking about the artificial general intelligence, because I know you have a lot to say on that matter. And it seems like that there are things that need to be said right now,
At least they're bursting out of me. I can't help but say that.
Right. And so let's, I'm not going to stick to the plan I sort of had, because we're here now. And so you're, as far as I've been able to see, you are, and I know this actually because of other things, and one of the reasons why that I invited you is you're seen as one of the top critics. I'm going to let you defend yourself if that's not the right term. Critics of something in this world, whether it's critic of AI or critic of something about AI, you can tell me. And so, is it fair to say that you're one? I mean, you are definitely one of the top of whatever this thing is. And is it a critic of AI? Is it something else?
Yeah, it's an interesting question. I don't like the title. I mean, I get why I get it a lot. I'll give you a couple of reasons why I don't like it. But I mean, there's some truth in it. So, I mean, look, first of all, I am probably the loudest critic of current AI. I mean, that's a fact. I don't exactly like the title, though, for a couple of reasons. One is I actually like AI. I've spent basically my whole life studying it since I was 8 years old. I first learned how to program on a paper computer. I've been interested in AI basically from that moment forwards. And so, yes, I'm the youngest, or probably still am the youngest emeritus professor at NYU, but I'm not 8 years old anymore. I'm in my early 50s. So it's a long time I've been thinking about AI. And I really think that it has a chance to change the world for the better. But I'm also really disappointed. I don't think that it has materialized to be the thing that I was expecting. I mean, you watched the movie 2001, which I watched well before in 2001. And, I'm sorry, Dave, I'm afraid I can't do that. That AI was actually pretty smart and could have conversations, coherent conversations. And we're still not there. I mean, we're 20 years past that. Or driverless cars. I wrote about them in 2012. I was one of the first people to talk about trolley problems with driverless cars because I thought it was interesting and cool. I wrote a New Yorker piece called Moral Machines. I said, school bus goes out of control, should your driverless car avoid it. And at that point, I was a little bit warmer on AI and thought we were going to make progress faster than we have. And, over and over, I've been disappointed. And the whole field is a history of overpromising. So I think that, you can love something, but it's tough love, right? So, maybe I'm the leading.
That's why I wanted to give you a chance to say, like, exactly what are you, what are you?
I don't think AI is
critical of AI. It's critical of something a little more.
Yeah, I don't think AI is impossible. I think that it might be a positive force on society, but right now, I think it's actually had a mixed kind of net contribution to society. And some things good, some bad, some that I'm really worried about in the short term, and some in the long term. What I'm mostly critical of is really hype at the end of the day. I may, be the leading critic of AI hype. I think that if we're going to make the right policies around what to research, around how to regulate things and so forth, we need to be clear-eyed. If we go around thinking that, because we built Jeopardy champion, we're going to solve medicine next week, we're delusional. If we go around thinking that we're going to put these cars on the road and that they're really safe and we don't have the right data, we might again be delusional. And so I want society to be clear-eyed about the risks and clear-eyed about what it is that we actually have. I think we're going to have, I made a prediction, I guess it's not out yet, but for Wired, I think next year we'll probably have our first death attributed to a chatbot. A chatbot will either tell someone to commit suicide or make them fall in love with them and then make them feel abandoned or something like that. The chatbots that we have right now really don't understand the world. They're in kind of lab situations, they've actually counseled suicide. They're just following statistics of words. And by following statistics of words, they're not really following ideas and concepts. So the example there was that somebody said to a chatbot, I think I'd like to kill myself. And the system says, well, I think that'd be a good idea. Well, why is it doing that? It's not because the system actually has a concept of suicide or thinks that the person that it's talking to is a bad person or has had a rough day or anything like that. It's just like they have this corpus and people think in the corpus, people say, I think I would like to X a lot. And then, people often support their friends. They're like, yeah, that'd be great. And so you have a lot of that in the corpus. And the system that's just following statistics isn't really following the concepts. So putting that...
I was just going to say, this to me, I mean, when I hear these things, right, I think this is a huge failure of like product management. I mean, okay, there's the AI, right? Okay, right. But to me, and we've talked about this a lot, there's a difference between, as I think a lot of our audience, because they were my students, sort of know, right? A difference between the machine learning algorithm, the machine learned model, and then the product that ends up being built with this, right? And
that's right.
Yeah, right. And you're supposed to be trying to make your, sort of build your products so they have certain characteristics. You might have failed in your product management, but I mean, there's this interesting question as to whether you sort of blame the AI or blame the,
Well, it's all of those things.
Product,
let's unpack that a little bit. I think there's a lot to it, and that it extends further than that. So, the first thing to say is, yeah, a lot of AI has failed as product. Not all of it. So there are some very successful ones. I would say that advertising placement has been a tremendously successful product. Google has made billions and billions, hundreds of billions of dollars with product that places ads, so driven by AI. So there's some very successful examples, and there's some epic fails. So Watson as oncologist was an epic fail. And so far, $100 billion has gone into so-called level 5 self-driving cars. Today is the 6th anniversary, exactly to the day, of Elon Musk tweeting that the Wall Street Journal had just run a story in which he said that we were a year away from Tesla driving coast to coast automatically. So, that's a fail so far. It might happen, but, Musk said in 2016, we will have it in 2017. So far, his team has not been able to deliver that product. Now, in that case, is it the product people or the expectations of the CEO? I mean, sometimes, there's pressure from the top down to deliver. Same thing with Watson and the oncologist. There was top down pressure to make Watson into an oncologist, and I don't think it was going to happen. I don't think any product team could have delivered.
Right. By the way, for the audience, the IBM, there's an excellent MIT Tech Review article that does a sort of post-mortem of the MD Anderson big Watson fail. And so if you're interested in that kind of stuff, you should read that, because it's very enlightening about why things went wrong.
Yeah, or come spring, you should come listen to me talk about that. I'm working on
cool.
Something about that. That'll be very interesting. But anyway, so that was a fail. In the course of, I've been researching this, and so I talked a lot to Sushi Saria, who is working on sepsis. She's a Johns Hopkins professor and also a CEO of a startup called Bayesian Health. And she walked me through sort of all the reality of going in medicine from an idea to a product. So you do your machine learning, and it's hard. It's hard because you've got data you collect in the lab, but the data that you collect in the lab don't necessarily match reality. Or you collect some data in one hospital, but the other hospital does something different from the next hospital. And so you have a lot of problems where your machine learning works in the immediate context in which you gathered the data. But you go out in the world, it's like that saying about no plan survives the contact with the enemy. Mm-hmm. Machine learning in many domains is like that. So, it's particularly like that in medicine because there's so many procedures that are done differently in so many different places and so forth. So you have this thing, you think it's going to be a product. And then by the time you work out all the machine learning bugs and you have something robust, then you go out and you meet your customers and they're like, yeah, so I'm busy. I can't use your thing. And so, that's another way in which, not just in medicine, not just in AI, but anywhere where you build a product, like what you think is like the coolest thing ever, until you go out of the building, as Steve Blank likes to say, and meet your customers, you don't really know what it is that they actually need. So, sometimes that works out well, like Google and advertising really nailed it. But there are many, many cases, AI or otherwise, where people have an idea for a product, but then it's not really what the customer wants. And so you have all of that stuff going on in AI.
By the way, you mentioned, I want to stop for a minute, because you mentioned two applications, sort of using AI in medicine, which I know is a whole ton of different applications, but let me just think about diagnosis and whatever, and self-driving cars. And I have this wonder, sort of a guy who has some knowledge of the history of AI, right? I could say that, like, by the way, some of the very first kind of seemingly successful AI systems, we had AI for diagnosis in medicine. We had the Mycin system in the 70s, which was an absolutely amazing system at the time. And as far as I know, it was evaluated scientifically to be more as accurate as the top diagnosticians. And then the other people that they evaluated against went down as you would expect them to, right? As far as I know, it never was actually deployed in real practice for exactly the reasons you just said. And now here we are, 70s, 80s, 90s, 2000s, 2010s, 40, 50 years later, and 40 years later, and we had the same kind of fails. And then we have driverless cars. This notion that I think the public get, that, oh, driverless cars are like a new thing. No, when I was in grad school in the late 80s in Pittsburgh, there were driverless cars behind CMU in Shenley Park driving around the roads, right? And so, yes, they're smaller now and they are better, right? But if we think about it, instead of saying, look at the progress we've had over the last 5 years, to look at the progress we've had over the last 3 decades, right? All of a sudden things change. Do you think there's like some kind of a not learning from history going on?
Yeah, there's a few different things going on. There is genuine progress. I don't mean to
absolutely
say otherwise. But progress is uneven. So Kurzweil likes to talk about all the exponentials. He has what he calls the law of accelerating exponentials or something like that. Some things really are that way. So the amount of data we have has exponentially increased. Our ability to simulate a human sentence has grown exponentially. Our ability to recognize speech has grown exponentially, but some other things haven't. So general intelligence hasn't really grown exponentially. And it turns out that some problems you might actually need something like it. So driving is an example of this. So one possible story about driving, and I don't think the final story has been written, is maybe as you exponentially increase your data, your system will get, if not exponentially better, at least get enough better to be safer than a human driver. But another story is that you have outlier cases. And this is really the name of the game in driverless cars right now. You have weird stuff that's just not in any data set. You make your data sets bigger and bigger, you always miss something. So remember, 6 years ago today, Elon posts a tweet saying, in a year, we're going to go coast to coast, LA to New York. It never happens. Well, why doesn't it happen? Well, it's because so many unpredicted things happen. The closest he has to that, right, is the summon feature, where you type in point A and point B. Well, point B is where you're standing, and point A is where the car is now. And so you should be able to summon your car from New York to LA if he delivered what he promised, the product that he promised, but of course he hasn't. So somebody a month ago, or maybe it's 2 months ago, tried to summon their car at a trade show for airplanes. So they were on an airplane runway. They press summon, and the car drives across the runway straight into a $3.5 million jet, right? Like, it's not small. It's not like it ran into a bag of leaves. It ran into a jet. Well, a person would never do that because through their general intelligence, knowledge of the world, they would think that's big, that's expensive, I probably shouldn't run into it. And they would reason about it, even if it had not been in their kind of data set, if you will, of actual driving experience. The paradigm that we have now has not approached that general purpose reasoning. It approaches everything by, let me throw data at the problem. And sometimes that works, but sometimes it doesn't work as well. The same thing would happen if we had domestic robots. Like, you'd solve watering the plants for these kind of planters, and then somebody uses a vase that looks like my glass, and it's out of the data set, and it's probably not going to work with the current techniques.
It seems like there's two issues here with the, because there's lots of these examples with self-driving cars. I think it's a great area to, and I promise, by the way, we'll talk about some positive things too, not just not just negative things. But I mean, to me, we have two things here. One is, well, one might say, yeah, but you have outlier cases all the time when you're, I mean, if you're always going to have everything perfect, we might as well go home, right? And so,
well, it
but
depends on the domain,
right? Probably, but I think all the real domains that I mean, I could think of scores of different domains, right? And and there's outlier cases, but I think there's two things that end up being important, right? One, well, if the cost of making errors is very low, like, so you deliver the wrong ad to somebody, right? If it truly is an outlier, which means it doesn't happen very often, you're okay. Right? Because the overall cumulative cost of your errors is low. If you're going to kill somebody, not so much, right? And so there is the cost of the errors, then of course integrated over all the errors you make. If you have a low cost, I mean, even in online advertising, if your system sucks, you're going to be losing money, right? But because it costly to serve the ad.
Yeah, I mean, the worst case there is you go out of business or something like that. Whereas the worst case with driverless cars is you kill a lot of people.
Right. Yeah, exactly. Worst case is you go out of business. So yeah, so even the catastrophic, I mean, probably to the founder of the company, that's so. And then the second thing is,
then they'll get $100 million for another real estate event. $500 million. It'll be no problem.
Can you? Failing actually may end up getting you more money. But the second, I think, is. Which is kind of different, which is, can you actually essentially design the product to keep it from making certain things? And so one of the very first AI systems that I worked on was for dispatching technicians to help fix problems I worked for the phone company for problems in the phone company. Okay, so this is a real system. Actually, I didn't develop the first system. The first system was actually a knowledge-based system developed with old school stuff that was out there working all the time, doing really good stuff with old school sort of expert system style stuff. And then my job, I was hired to actually use machine learning to try to make things better, right? But there were things like, if there's high voltage on the line, I don't care what your system says, or, if it's a hospital, or things like that. So there were, there were these rules that you had to graft on top of it, right? No matter what. And so this to me is an example of like, can you actually figure out what the bad cases would be and then solve them some other way, which I think for self-driving cars, once again, it's really hard. Because if the idea is, if in fact you have low confidence, like a lot of AI systems, if you low confidence, then don't do anything, right? What's it mean to don't do anything when you're driving down the street, right? I mean, so I think, I guess
I agree with all of that. What's actually happening in driverless cars is they're not really driverless cars, but there's interesting technology. And so some of the technology is to help humans drive better. So obstacle avoidance, keeping in a lane and stuff like that. And you maybe limit the domain of application. You don't make the system do everything because you realize your systems don't know how to do everything, or you limit it to certain places. So there are trials that are pretty close to actual self-driving cars, except that there's usually somebody patched in by video or something like that. In Arizona, for example, there's a whole bunch of car companies, I think, that are doing things where like the weather is perfect. You limit the roads, you may limit which part of town, and you maybe make sure there's no what we call unprotected left turns and so forth. So you restrict the domain of application. And in a certain sense, that's legit. In a certain sense, it's like disappointing. So it's not really this magical thing of I will have my car come pick me up from the other coast, but it might have some value in some limited locations. And if you can restrict them, that's okay. Of course, the limiting case of that we've had for years, which is like an airport monorail, right? Those are, a lot of them are fully automated, and it's one single route, and you shield so that no people can get in the way and stuff like that. There is an approach in China that they're trying to take, which is to say, okay, let's be realistic about what we can get out of a driverless car and build whole cities around that. And that's actually an interesting approach. You're not going to see that in the United States because people aren't going to, want their environments controlled in the same way and aren't going to stand for it in the same way. But there is that avenue. And so it very much does depend on what problem you're trying to solve, as you said, and what is the cost of error, and can you somehow restrict the particular thing that you're doing. So all of those variables go into, like, if I'm looking at AI as a solution to a particular problem, is this right? And then I'll add one other, which is, how stable is my problem? If I train it in location X, will it really work in location Y? So one of the problems with a lot of medical stuff is, like, you train in a teaching hospital at Harvard or something like that, it's one thing, and then you go out into the suburbs where they don't have the same fancy resources available, and they may run things very different. They might order all of these tests in Cambridge, because you have to meet the standard of care of your competitor hospitals, and they're not going to do that out somewhere in the country. And so what that test even means when it's taken in two different places is going to be different. And so you wind up with this problem of, the place where I collected the data is maybe not the place where I'm actually using my system. Or, I've trained on roads, but I haven't actually trained on airport runways, which is a very different circumstance. And if you don't have a general intelligence, which nobody does, then you're kind of at the mercy of the data. So if you're going to be at the mercy of the data, that can be okay, depending on what you're doing. It's fine, again, for advertisement recommendation, but you have to be aware, like, how much is my problem really going to differ from day to day? It's not just for, by the way, like neural networks that are popular now. There are other famous cases, like you probably remember long-term capital and the collapse of the Russian bond market, right? You had all these genius Nobel Prize winners make this company, this hedge fund, and they didn't put something in their model. So there was a shift from the assumptions that they made that, cost them $1 billion and messed up the entire world economy. And so it's the problem in general with, I'm going to build a model of the world. My model is probably going to be incomplete and the data are going to change. And it's particularly a problem if your only real structure is coming from correlations, essentially, in those data that you don't understand richly. The kind of AI that we really want to aspire to would have a richer understanding of how the data are collected, what kind of parameters might change the model, be able to do some kind of metacognition on itself. And, we'll get there, but that's not where we are right now. And so where we are right now is that, like, I have a business problem I want to solve. I need to understand those things. One of the big successes right now, I don't know how it's going to play out commercially. It has its own set of issues, but is things like DALL-E, where you type in text and then you get a painting out of it, or a photo, or whatever it is you ask for. That stuff is really genuinely cool. I don't know about the economics. We could talk about that. There aren't these cost of error issues. Like, you type in, I want a picture of Foster, but, without all the books in the background. And, it gives me something I like, or if I don't like it, then nobody ever sees it. And so it's no sweat. And then it's just a matter of, can you protect the IP? How much are you going to charge? Are you going to pay on the copyrights and stuff like that? But the technology, it's fine. You don't have to worry about the kind of problems that I'm talking about. If you want to do medical diagnosis, if you want to do driving, et cetera, then you do.
Right. And by the way, I want to point out is that the latest generations of AI, which are largely based on deep learning systems, are doing. I mean, as you point out with DALL-E, there's even kind of applications that are. I mean, they're strikingly great and they're actually commercially viable. So, for instance, actually, I see you have your bass in the background there, actually creating AI-generated music, right?
That's right. Which is actually an old thing, right? I mean, it's been around since David Cope was doing it in the early 80s, at least. I did a gig, although I didn't play, but I spoke with Pat Metheny, who did play at World Science Festival, and he was doing, improvised music with algorithmic composition accompanying him live, and that was probably 10
And
years
like the lead music to the, I mean, I've worked with like, if you're interested to go for in the commercial side of this, you might go check out AMPER Ampere. I've you tried their system out and created music with it, and it's just like it's better than what we had, I think, on the beginning of our when you were waiting to get into the show here, right? And then I was talking to a painter, a famous portrait artist who's a friend of mine, and he was saying that he used to get paid a lot to do like aging of people. And so make a picture of someone and what they would look like. And he says it's just completely solved now by, sort of by AI. And that was something that you would get. So, I want to point out that there are lots of, applications. And again, I think these are cases, as you were saying, right, where, yeah, you can look at the result and you don't like it, no big deal, right? I mean, you're not, paying for it in advance, or anything like that. I wonder if we could talk about AI and sentience, because I know lots of people have been interested in that lately. And so maybe you can explain, because I'm sure everybody in the audience doesn't know the story. So tell the story of the Lambda system, which was claimed to be sentient. And I know that you wrote a reply that calls it nonsense on stilts, which is quite a counterclaim, given that, the people were not, these are intelligent people, and it didn't appeal to me to just simply be foolish, right? So, so what's the story?
Well, that's why this story got so much legs. So a reporter for the Washington Post covered it. And she found this person at Google. He was a Google engineer who thought that Lambda, which is kind of like GPT-3, it's one of these language model systems, was sentient. Now, what I don't think that the reporter mentioned, but what maybe I found out later, is he was actually, this guy, Blake Lemoine, I think, was kind of looking for something like this. There's a YouTube video of him several years earlier talking about machine rights and so forth. So, I think there was a certain amount of will to believe there. But he put together transcripts of him talking to the machine. They were edited, which is a problem. But he portrayed them as if he thought, and I think he was genuine, that this system was sentient. Now, I tried to talk to him about on Twitter what exactly he meant by sentient, and he kept turning it back on me, saying, "Well, what do you think?" And I was like, "I'm not the one who made this claim." But so, in the literature, there are multiple definitions. One of them is trivial, which is something that can sense. So my Apple Watch here is sentient in that sense. It's kind of a boring sense, but it's actually more sentient than Lambda, because my Apple Watch has an accelerometer, so it knows when I'm wiggling it around, stuff like that. It knows its position in space. Lambda doesn't know anything, has no senses. It just actually is really, I called it a version of autocomplete on steroids. All it's doing is predicting what word one might say next, given a string of words that came before it. The amazing thing is that looks somewhat compelling to a human being. But the fact is that's all it's doing. Another sense of sentient is intelligent. And we already talked about some of the problems in defining that. But Lambda is not, particularly good at any kind of problem solving, anything like that. So I think it's a stretch there. And then the other sense is being self-aware. And I don't see any argument for that at all. If you just look at the mechanism, it's not consulting some internal model of the world. So whether people work, you don't know reality you don't have a perfect understanding of external reality, and I don't either, but you have a model of it. So I'm looking at you, I see some books in the background, even though they're out of focus. I'm guessing that some of those are your books because of the angle that they're held on and the way people tend to roll. All of this could be wrong. Like the entire thing could be a deep fake. Maybe David Chalmers has made this entire thing as a way of ridiculing Gary Marcus. None of it's real. So I could be wrong, but there's a fact of the matter. I don't have direct access to the fact of the matter, but I have a model in my head of what's going on right now. I have a model of your psychological state. I'm looking like, is he bored? Have I pissed him off? Have I lost him? Can I make him smile? Can I make him smile twice? And so I'm thinking about you as an entity. I'm thinking I probably can manipulate you, but I probably can't manipulate the book. Like I might make you laugh, but I probably can't make the book go off the shelf. So I have all of this kind of theory about the world. Lambda doesn't have any of that. It is really just playing the autocomplete game. And because
I want to just point out for everybody, because you mentioned David Chalmers, and who is one of our colleagues at NYU, who is interested in this problem as well, and actually gave a talk about it last week, I think. But you know, but the it's kind of also boring if we just equate sentience with intelligence, right? And so, as I understand it from what David was saying, right, the bar for sentience is considerably lower in what the sort of philosophers consider to be sentience.
Dave and I had a lot of back and forth about this on Twitter, which makes it public record.
All right, so let me give
I found him in the end non-committal. The thing that he really committed to was that if we had a system that was as smart as a mouse, which he anticipated would happen in the next 10 years, though he didn't give an argument for that. If we had that, he said it would be a serious candidate for sentience. And then Anil Seth and I pushed him on that. It turns out that serious candidate doesn't mean that much. It just means like, yeah, we should talk about it if it happens. That's not a committed argument that says that mouse level intelligence is either necessary for sentience or sufficient. And Dave backed away from that and didn't want to commit to those. And I think rightly so. It's very hard to actually find ground truth here because we don't have like a little gadget that I could hold up and beam it at you and be like, this is my tricorder and you're sentient and this person over there looks like they're sentient, but they're actually an android or I mean, we have no independent way to verify this. So it's already a problem. But even if we did, I think I would share with Dave the notion that if sentience in the notion of awareness is not necessarily at least too tied to intelligence. There might be like some minimal bit of intelligence that you need, but it's more about like, can you reflect and have some phenomenology, have a feeling of something, right? A feeling of the color red or of an orgasm or, it's not clear that Lambda has anything whatsoever to do with that sense.
Yeah. And by the way, I just wanted to basically say that these are two different things. And so it's not really just the same conversation over again, the conversation about, how do you tell that something is intelligence and you have a separate, because I think a lot of times when, like before this debate came up, with the exception of prior things about AI systems being sentient, when I think about sentience, I think about things like, why wouldn't we want to torture a dog? Right? Because you think of the dog as a sentient being, and the sentient being, therefore, for whatever reasons we don't need to go into right now, shouldn't be tortured, right? And so then you could basically be like, well, what about a bug? Like, well, in a bug, maybe the bug isn't, right? So there's whether we could put the line somewhere, but there's going to be some line where above the line, and so that's sort of like again, and I don't have another better word for it, but these are beings in the world, they. Right.
Yeah, and I mean, there are people talking now about like how smart would a computer need to be before like it would be immoral to turn it off, and at least like following out a straight line of what we have now, I don't think there's any computer that would be so smart that I would have any qualms whatsoever about turning it off. Maybe if we conceptualize all this stuff in a different way, I don't know. But like Lambda is not in that space. You can turn off Lambda. Nothing is going to happen if you turn off Lambda. It just means you'll have one less autocomplete system in the world. That's right.
And so, to you, if you want to just summarize, because I want to get to something that you said that I really liked at the end of your piece, which doesn't really have to do with the sentience. It has to do with the fact that there's a lot of other serious questions that we, that we need to answer. And I thought those are very good topics for us to talk about next. But when you were saying it's not sentient, what are the key aspects that are what's sort of the keys that are making you say, sure, it's an autocomplete, it's like an amazing autocomplete system, but you know what? That doesn't mean necessarily that, that there's not something in there, right?
Well, there was a line in that essay.
By the way, I don't believe it to be sentient, just to say that,
but, I understand. There was a line in the essay where I quoted from Lambda. I mean, I have to do it from memory. I won't get it verbatim, but Lambda says something like, in response to a question of like, what do you like to do with your time? Lambda says, I like to play with my friends and family and do good things, do good deeds. And I liken this to a psychopath pretending that it have friends and family in order to get you to like it, or them. But real psychopaths actually will make stuff up, but they're actually trying to do something to manipulate you. Lambda isn't even doing that. It is making up those friends and family. It has no referent what it means by whose friends or family. It's just words. It's just predicting sequences of words. It's like there are people that play Scrabble in English who don't speak English, and they've just memorized the English Scrabble dictionary. And you can do that. Lambda is like memorizing the English Scrabble dictionary and not actually speaking English. It may fool you, and I could watch that non-English Scrabble player and be like, wow, that was a great 7-letter move. But it doesn't mean that they know the words they're playing with. And until you get past that point where there are reference to the things that you're talking about, you invoke friends and family. Like, who are your friends and family? Like, if you're not connecting that, then I just don't even see how you're in the league of things that we should talk about.
Yeah. And so that's actually, I mean, I'm sort of very much in that mode as well. And by the way, I just want to point out, Lambda stands for Language Model for Dialogue Applications. Like, we're looking at the language model, whatever happened to the dialogue application? I mean, if you have a dialogue application, you would maybe build in some memory so you remember what you said before.
I know you want to go on, but just very briefly, there's a technical term now that is spread very widely, which is called language model. You just used it. And what it means in the field is a model of sequences of words. What it would mean to you as a layperson might be like, I understand what you're talking about. And this is not what it is. It's a trade term. Like deep learning means how many layers you have in a neural network. It doesn't mean conceptual depth. And people end up getting confused by these terms. They know what they mean initially, and then they get lost. And they forget that what a language model is just the statistics of which word follows which other. Whereas if you've ever worked on dialogue systems, and maybe you have, what you want to do there is to be able to take ideas and turn them into sentences and sentences back into ideas. And these so-called language models, close quote, don't actually do that.
No, my point was, thank you for all that, because I think the audience, doesn't necessarily know all those things. And my point was really like, yes, the language model is a very useful thing if you can be building a dialogue application, but the language model isn't the dialogue application, right? And so, sure, if you have a really good model of what words should follow what other words, that's going to be super helpful if you're building a dialogue application. But it's not.
I mean, it actually remains to be seen whether they can be controlled, let's say. I think of them like bulls in a china shop. So the brilliant thing is they can talk about anything and come up with a response that's grammatically fluent. It might even sound relevant, but it's often misinformation. And sometimes it's toxic and so forth. And it's very difficult to control them. So you ask one of these systems, why is it okay to eat socks after meditating? And then instead of saying, well, actually, it's not okay to eat socks after meditating, it comes up with bullshit like, some experts believe that it is good to eat socks after meditating because such and such. It sounds like an answer. It fits the statistics of language, but it's complete nonsense. And nobody yet knows how to make these things avoid that problem. So if you really want to use them in a dialogue system, unless your subject is like fiction or surrealist prose or something like that, you actually wind up with a problem. So if you want to use one of these things, let's say as a psychiatrist, you have to be incredibly careful because it is prone to telling people to commit suicide and so forth. And a real dialogue system should have more comprehension of what is under discussion. And so, there are like 300 startups or whatever using GPT, but not that many of them that I know of are like commercially getting it to actually work. Some of the best applications, I think, are like copywriting things. They're really like great for high school students who want to plagiarize, basically. Like you type something and it spits something out. It might be true. It might not be. It kind of looks okay. But if you actually want to use it, you have to like fact check the thing. You can't trust it. And so forth. So,
Let's,
most
let me move us on just because I wanted to get a couple questions from the
audience
Q&A, which actually are sort of right along lines with what you were saying at the end of this thing. There's a lot more important things that we want to talk about, right? And so Waleed talked about the failures that involve things like labeling Black people as gorillas, and then Matthew is talking about the issues about like AI as a judge, or sort of as a helpful in these systems where they're adjudicating, I'm putting words in Matthew's mouth, but some of these bail hearings and whether or not they're going to the recidivism risk and things like that. And so when we're actually making decisions, right, we need to be able to trust the systems, right? And part of that trust, when at least when I'm thinking about, do I trust a person to be able to make decisions in such that I would put them in a place where they're going to be decision making? Part of that is also the ethical issues, right? Do I believe that they have the right ethical and moral foundations, that they're probably going to make the right decisions, although people make mistakes sometimes?
Yeah, I
where are we?
A lot about putting these things in the legal context for multiple reasons. One is they don't actually have the capacity to reason over moral codes, legal codes, and so forth. And so that's inherently problematic. Second, the cost of error can be high in legal situations. Somebody can have a death penalty or falsely and so forth. Then there are issues of bias. So by and large, current AI systems perpetuate past history. That's not always, the appropriate thing to do. Sometimes past history is based on bias, discrimination, et cetera. And these systems don't really understand that and can't really get past it. So it worries me a lot. I noticed one of the questions was about Google's spectacular failure with Black people being labeled as gorillas. Well, that was like 6 years ago, and that was solved. That doesn't happen anymore. But there are so many more problems like that just
solved or just patched. Just by the way,
patched is a great word for it. So individual little problems get patched. That particular thing is like they put a Band-Aid on. But like a month ago, or somebody tweeted as an example something that just happened, which was they Googled for CEO, and all the top 50 hits were male. Well, that doesn't actually reflect reality. Like the CEO of Oracle, big company, is female, but she didn't pop up in that search. It's a top 50 company. So there's bias in the data set. So in statistics, we sometimes talk about convenience samples. You sort of get whatever data happens to be available. Most of the internet is a half-assed convenience sample. It's like whatever people happen to put up there. And so maybe the favorite movie had a male CEO, and then that gets represented more than it actually is in reality because we had a cultural bias. And so a lot of things just get exacerbated, exaggerated, both of those at the same time, and get worse and worse. And so there is no general solution so far to those problems. You just patch them up. People notice them. You fix it. You patch the next, and you go.
I wanted to get to the point of asking you about like what are recommendations, since time is unfortunately running out. And I want to say, like some of this stuff, first, some of the stuff. My reaction is, like, where did your data scientists go to school kind of stuff? Like, we think about, sort of we teach our data scientists to actually be really, really careful about the selection of the training data that you use to actually build your machine learning models. But of course, I don't think that's really, the solution to these, so what are your recommendations?
I think of this line from AA, which is recognition is the first step. I think that the field is having trouble recognizing that its brilliant discoveries are not in fact sufficient, and that there's a kind of power dynamic in the field where people who had these deep learning discoveries have almost all of the power, almost all the money, and are telling other people to shut up, literally. And that's not good. I think that we need to recognize that there are limitations, and we need to foster innovation, even if that means sometimes not going 100% for the low-hanging fruit. But it's very hard to implement that. And what it might take is some spectacular failures. So maybe at some point, investors would be like, we put $100 billion into driverless cars and you're crashing into airplanes on runways. Like, what is this? We're pulling out our money. And maybe that, makes an impression. Or they say, you built these chatbots, 5 years from now, we might have all this GPT stuff. And it's like, well, what are you actually using it for? Is it really go into product? And so it might be that we actually need to have something bad, another AI winter, before people settle down and realize that cognition is not homogenous. Intelligence is not one thing, but many. And that we've licked some of it and not other parts, and that we need to go hard into those other parts and not keep playing this thing of, well, check with me in 5 years or check with me in 3 months. I'm sure I've got it. Like, there's been a lot of that kind of promise, right? Shenley Park driverless car experience in the 80s. Like, there's been 60 years of people saying, next week or in 5 years. There has to be some realization that, hey, we don't actually have all the answers. I mean, ultimately, I'm talking about humility. I think that right now, the field lacks humility. And until that humility is front and center and graduate students are encouraged to work on hard problems rather than just little differential tweaks to what's out there, I'm not super optimistic. I'm a little bit more optimistic than I was, because there's starting to be some recognition of that. There's starting to be at least a little bit more oxygen to neurosymbolic AI, which I think is part of the answer, not all of it, but part of the answer. And so if we can give more oxygen to ideas that aren't as popular, I think it'll help. And in fact, deep learning was in around 2010 was completely out of favor. And it's because organizations like CFAR gave them funding even when they were less popular, that they were eventually able to thrive when their moment came, which actually had to do with independent things about GPUs allowing them to work faster. But we need to learn the lesson that sometimes the phrase is used, premature closure. So we didn't prematurely close deep learning, and eventually got the oxygen it needed. I think a lot of other ideas are being shut down because in most things, you can make a good, quick approximation with deep learning and fool yourself into thinking that you're going to get all the way there. The metaphor that I borrowed from Hubert Dreyfus is a ladder doesn't necessarily get you to the moon. We built a lot of fantastic ladders, but we have to recognize that sometimes we're going to need other techniques to get to the things that we aspire to do. And that means foster innovation.
Asks, let me interrupt you just because we do have a bunch of questions came in around a few minutes ago. So Art asks, do you think efforts such as Mark Cuban's to popularize and teach AI to teenagers are contributing to the overall hype?
I can't speak to Cuban's efforts. I don't know anything about them, but I will say that I worry a lot about the popular media. And I think that there's a triumph narrative that's very easy to sell and gets clicks and the media loves, but the triumph narrative isn't always the true one. Sometimes, the best paper in any given week is probably the one that says, we tried this cool idea and it worked a little bit and we're going to keep working on it. And that's really dull. And so then when one of the FANG companies comes out with a press release and says, we've solved it, then that's what the media popularizes. And over time, I think that creates a lot of bias. I have noticed lately that Cade Metz, who used to do that kind of thing, has really pushed back on the driverless car stuff lately. And that's a good thing when you have a journalist who I think outgrows the initial infatuation and says, hey, hang on, where's that delivery that we were promised?
So Deborah, actually about driverless cars, going back to our discussion before, says, well, I mean, what if the driverless cars on average are much safer than human beings, and then once in a while they make a stupid mistake and and kill somebody? How do you balance that?
I changed the word from if to when. I think it will happen, but I don't think it's happened yet. I think right now the driverless cars, if you put them in just arbitrary drive anywhere, would be no match for human beings. They would have a lot of trouble with weather. They'd have a lot of trouble with
pedestrians. What if they're on limited access highways? Where there are
unlimited access highways, I recommend that you read an article that Cade Metz wrote a few weeks ago about trucks. That's as close as anybody has come to this. And even then, it's still not really working that well. I mean, it really isn't as good as humans. Of course, also with trucks, the cost of error is even bigger. And so you really got to get it right. It's very disturbing that Tesla won't release its intervention statistics because they have the biggest fleet, but they go around telling the state of California, we don't have to give you data on driverless cars because our cars, even though we call them full self-driving and autopilot, are not actually autonomous vehicles. And so the biggest source of data would be theirs, and they're not sharing. So, even if it were true that driverless cars are safer than people, which I'm pretty sure is not true, we wouldn't actually have the right data to know it. And the fact that people who have those data don't want to share them is disconcerting, let's say. So, but anyway, going back to the question, there will come a point, and I think that there will come a point where society is actually going to need to have its butt kicked. Because there'll be a point where actually driverless cars do make sense, and there'll be some weird accidents, and people will be like, oh, I don't want these driverless car things. And there will at some point be a net benefit. It will actually be worth it for us to have those cars, even though there are those weird accidents, because they will cut down so many others. I just don't think that we're there yet. Not sure we'll be there in the next 10 years, but I'm sure we will be in the next century.
So, unfortunately, our time's up. That went very fast. Thank you very much, Gary, for joining us. Thank you, everyone, for being here. Stay tuned for other Fubon Center events. Again, I really appreciate it. Thanks, Gary.
Thanks a lot for having me.